All right, let's go ahead and get started. Thank you everyone for joining. Everybody having a good conference so far? Yeah, good. So this will be the session on automating DevOps between Service Manager and TFS using SMA. But when I originally proposed this session, that's how I thought that I was going to take this. And we actually built some things using SMA and ultimately ended up deciding to use Service Manager and TFS workflows instead. So I'm going to talk a little bit about how to do this with SMA, but also just to give you some other options, I'll talk about how to implement integration between Service Manager and TFS using Service Manager and TFS workflows in the Service Manager SDK. So let me introduce myself first. I'm Travis Wright, and online I'm known as Rad Travis, and sometimes people ask me, well, what makes you so rad, right? And so there's kind of an interesting story behind that, and it kind of is a good intro to our session today. So although I grew up in a time when rad was a popular term, I was really not very rad at that time. I was wearing a three-piece suit, as you see here in this picture. I was definitely not rad, and just for clarity, that is not my girlfriend, that is my aunt. So, okay, so I started out my career at Aquantive. I got a business degree in school, and then I started working at Aquantive, which was later acquired by Microsoft for $6.5 billion, which I never saw really any of that money, unfortunately. But at Aquantive, I was a business analyst, and at the time I was sort of just interested in technology in general, and I was reading this book called Iterative Development, which talked about the concept in software development of rapid application development, or RAD. And I created a tool while I was there that automated a process that I had to do every day. My job as a business analyst was to copy and paste spreadsheet content from one spreadsheet to another, to another, to another, in order to load advertising campaigns into the ad serving system. I was literally Control-C, Control-V all day long. It was really super boring. And so I decided this is dumb, and I learned how to program in Visual Basic for applications and wrote an Excel add-in that automated that entire process. So that process that would normally take like 4 hours of just copying and pasting, just mind-numbing work, could be done in about a minute with this tool, this add-in. And I called the tool the RAD tool because I was learning rapid application development, and I had my wife record her voice saying, "Ooh, RAD tool," at the end. So every time somebody would run the tool across the floor, you'd hear somebody's computer go, "Ooh, RAD tool." So that was sort of my introduction to software development. So at that point, the software development team thought that was pretty cool, and so they brought me over into the software development department, and I became a developer. And so I spent a couple of years as a developer there, and I realized that I was never going to be a really good developer. I could write some code, I could do the job, but I realized that I just really wasn't going to be a superstar developer. And so at that time, I switched over to becoming a program manager at Microsoft, and I spent 11 years at Microsoft as a principal program manager working on the System Center suite, mostly on Operations Manager and Service Manager. But that gave me a good combination of sort of technical skills as a developer and the business analyst sort of background I had, and kind of put those together into one. And I really loved that job while I was there at Microsoft. About a year ago, or a little bit more, I joined Cyerson, which is a System Center ISV and SI partner. And that has been a very interesting experience because now not only do I lead the software development team at Cyerson building software solutions around System Center and in particular Service Manager, but we also operate Service Manager and our software in a production capacity to support our customers. So our customers use our self-service portal to be able to interface with us whenever they need support, either to search the knowledge base or to report an issue that they have or request some feature, request product keys. All those kinds of things come in through our self-service portal. And so as a result, I've kind of become an IT guy now. And so I can sort of much better understand IT people now, having been an IT person, so I can empathize with you a lot more. And we've recently migrated to Azure, and that was a very interesting process. We learned a lot, and I can definitely sort of empathize with IT people's challenges a lot more now because of that experience. And I'll actually be talking about that tomorrow if you're interested in that session on how to operate Service Manager in Azure. But kind of the combination of all of these different roles that I've had over the few years has kind of led me to being somebody who has a different perspective on how development and operations should work together. And really, if you think about it, rapid application development was really just the beginning of what is now known as Agile software development. So how many people here are familiar with Agile software development, or is it kind of a new concept to most people? Okay, I figure it's probably new to most people because you're probably IT people. Agile software development is obviously about software development. So I wanted to give you just a little bit of a background on Agile software development before we go into the rest of the session today. So the idea with Agile software development is to take the normal process of software development that really normally takes a long time, historically took a long time. So you think about like a Microsoft Windows release, and that would take 2 or 3 years. Every major release of System Center would take 2 years, for example. And the idea with Agile software development is to break down a long release cycle into many small iterative releases. So the idea with that is that you can be more responsive to your customers, and we'll talk about that more in a minute, because instead of having one long release cycle that you plan, and then you develop, and then you test, and then you release, there's an opportunity to get customer feedback more often and adjust your plans accordingly as you go, instead of having to build one long thing, and by the time you get to the end, maybe what you built isn't even what the customer wants anymore because it took you so long to build it. And so that's the idea with incremental software development, is to build it all at once. So I love this poem by Shel Silverstein. He talks about Melinda May, who's asked to eat a whale, and is asked, how are you going to eat this whale? And she said, well, I'm just going to start at the tail, and I'm going to basically eat it one bite at a time, right? And so that's the idea with Agile software development, is you have a big goal, something you want to build, but you break it down and just do it one bite at a time. So the way that it works with Agile software development is it's all about iterative development. And so every iteration is also called a sprint, and that's a defined period of time in which the development team will accomplish some scope of work. Typically, an iteration is maybe 2 to 4 weeks long. So you have a 2-week period in which you decide what you're going to do, and you go and achieve just that 2 weeks worth of work, and then you release that improvement that you've made to the customers and get feedback from them on it. And the way that this works is that you have a big master story list, a backlog of things that you want to accomplish, the customers have asked for. And these stories are a complete end-to-end user experience to accomplish something. So a story might be something like, as an asset manager, I want to view a dashboard chart that shows all the install counts of each of our software titles. So that's a well-understood story, something that a user would want to do, and we can define more specific requirements underneath that, but we would then put that story in our backlog, and then each iteration as we go through sprint planning, we would choose which stories we wanted to achieve for that particular iteration. Then we would go and work on those, and then at the end of that, we would release it. And that list of stories that you have is called the backlog. So the whole point of Agile is to be responsive to your customers. And so the idea is that once you put out a sprint release, you give that to customers, you get some feedback on it, and you immediately take that feedback back into your planning for future iterations. And the idea with this is that you as IT people, you play a key role in this process because you are the interface of the development team to customers oftentimes, right? So if you have an internal development team and they're building a line of business application, or even if it's a third party that's providing some software that you're providing to your customers, either way, your customers generally aren't talking directly to the developers or to the third-party software provider. They're using IT as their interface to the dev team. And so the way that it kind of works, right, is that you start out as the development team here, and the development team produces some software. The IT team then releases that to customers. The customers use it for a while, and then they provide some feedback. That typically goes to IT. And then IT should provide that feedback to dev, and then dev uses that to improve, and you kind of go in this cycle. So here's another way to look at it. You start at the top where you have customers using the software solution, and they provide bugs and feature requests. This is customer feedback. That then should go into the backlog for development, and then they prioritize and plan. They develop whatever it is that needs to be developed the customer is asking for, and then it gets released. And if you think about it, this line right here that I drew, that's the difference between ops and dev. So dev is down here doing the prioritization and planning and development, and up here when it's in customer use, that's obviously like an operations function. But release and customer feedback are an area where development and operations can work together. And historically, that collaboration is not always very good, right? It's sometimes hard to get the developers and the IT team people talking together. Usually when development and IT teams are talking together, they're usually pointing fingers at each other, right? It's you guys who created that bug. No, you have it configured wrong, right? And so what I want to talk about today is how we can improve the collaboration between development and operations by using some automation between Service Manager and TFS, and some other automation in general. So we'll talk about how at each of these two phases in the feedback improvement cycle, we can automate some of this and improve that collaboration between development and ops. And one thing to point out here is that typically an ops team is using a tool like System Center Service Manager. That's like their service desk where they're collecting customer feedback, bugs, feature requests, and so on. And the development team is using a tool like TFS to manage their work items. And there's no way we're going to get dev to use Service Manager, and there's no way we're going to get IT people to use TFS. So what we need to do is have a way for these two tools and these two processes to work together. Because if you think about it, operations is using a process framework like ITIL, and development is using a process framework like Agile. And those are two different process frameworks, right? So what we need to do is we need to find a way that development and IT can work together despite using different tools and different process frameworks. And that's where the automation can help. So to begin with, I want to just introduce a few things about PowerShell workflows. How many people are familiar with authoring PowerShell workflows? All right, just a couple. Good. So this will be something new for you then. How many people would say that they are experienced PowerShell script writers? Not even really that many. Okay, good. All right, so there's a few things to know about PowerShell workflows. First of all, a PowerShell workflow is a PowerShell construct that's similar to a function or a commandlet, but it's actually something that is compiled down and executed at runtime as a Windows Workflow Foundation workflow. And so in that sense, it's more like code that you write in a script-style language, and then it's compiled at runtime. Workflows are different from PowerShell scripts, though, in a few different ways. First of all, they run as activities. So Windows Workflow Foundation has this concept of activities, and when a workflow executes, it executes activities inside of it instead of commandlets. Commandlets can be run inside of a workflow as long as those commandlet calls are inside of an inline script block, which I'll show you in a minute. Some PowerShell commands don't work unless they're inside an inline script block. So you may sort of assume that you can use any sort of PowerShell commandlet inside of a workflow, but that's not entirely true. Only PowerShell commandlets which have been converted to Windows Workflow Foundation activities can be used within a workflow. You can use commandlets inside an inline script block inside of a workflow, though. We'll see some examples of that here in a minute. Workflows can execute commands in parallel or in sequence. So a PowerShell script is a procedural language. It doesn't have an ability to have a branching logic and execute things in parallel or in a particular sequence within a parallel action. Variable lifetime is handled a little bit differently. I'll show you an example of that as well. One really powerful thing about workflows is that they can persist state. So at any point in time, you can persist the state of a workflow and then come back to it and resume it at some future point in time. And that same technology also allows for workflows to survive a operating system reboot or a network outage. So if you have a PowerShell workflow running and there's some network outage or the computer's rebooted, the PowerShell workflow runtime will continue to try to execute that workflow until it's completed. All right, so let's take a look at a quick Hello World example of a PowerShell workflow. So in this case, the first command that I put here is workflow hello world, and then inside this curly braces just a string hello world. So the workflow word here just declares that I'm creating a new workflow. I give the workflow a name, hello world, and then I provide the command that I wanted to execute inside of the curly braces. In this case, I just wanted to output to this standard out, hello world. And then the second command I provide there is to call that new workflow that I created. I just type hello world, and you can see the output is hello world to the standard out there. That's just a quick hello world of how to create a PowerShell workflow. Now, PowerShell workflows can also have input parameters, and you can use parameter sets. You can make parameters mandatory or not. And just a couple tips there is that parameter names can only be letters, hyphens, numbers, and underscore. And if you do use a hyphenated parameter name, it has to be enclosed in quotes. Here's an example of using an inline script. So here we've declared a workflow called inline script example. Then I have an inline script block, and inside of that inline script block, I can use PowerShell commandlets. So in this example here, I'm using the get process PowerShell commandlet, and I'm piping that to a where object where I look for a process with the name Explorer, and then line 8 there, I simply am calling this workflow. So this is a PowerShell script I wrote that declares a workflow and then calls it. And then if I execute that PowerShell script there, you can see the output. So that's an example of using an inline script. All right, how many people are familiar and have used SMA? Okay, a similar small number of people. All right, so now I'm going to do an introduction to SMA. SMA stands for Service Management Automation. Service Management Automation is a component in the orchestrator setup. So if you have System Center Orchestrator, you have SMA. You can simply install SMA as one of the components that's in the orchestrator setup. And SMA provides you a browser-based runbook authoring experience that's built into the Windows Azure Pack admin portal. So in order to use SMA with a user experience anyway, you also have to have the Windows Azure Pack admin portal deployed. So there's a couple different things you have to do here. One is you have to deploy the SMA runtime and database and API layer and the PowerShell commandlets for SMA. And then you also have to install the Windows Azure Pack admin UI and connect that to your SMA web service. The great thing about SMA is that it provides support for high availability and scalability. And you can use any PowerShell module in the context of SMA. So the SMA has an interface where you can import in any PowerShell module, and it will automatically convert the PowerShell commandlets in that module to Windows Workflow Foundation activities that you can use inside of a workflow. So you can imagine all of the different modules that are out there at this point for System Center, for Windows Server, for Exchange, SharePoint, SQL. I mean, there's an endless number of PowerShell modules now, and you can import any of those to be used inside of SMA as an activity in a workflow. And you can also go to this Building Clouds blog for an introduction to SMA. So how many people are using Orchestrator right now? Okay, quite a few people. Good. So if you were to kind of compare and contrast SMA versus Orchestrator, a few differences are that SMA has 64-bit support, so you have a greater addressable memory space. It also has native execution of PowerShell, which Orchestrator is not really designed to run PowerShell. That was something that was sort of added later. Orchestrator was built long before PowerShell even existed, and so those of you that try to use PowerShell inside of Orchestrator are familiar with some of the challenges there. One other nice thing about using SMA is that you get all the benefits of workflows. So you get parallel execution of your commands, you get persistence of state, you get just kind of these different benefits of the PowerShell workflows we just went over. One key difference, though, is that the SMA UI is a text editor for creating your workflows, whereas Orchestrator is more of a visual drag and drop and configure type designer. So if you're really good at writing PowerShell scripts, then having a text editor may actually be better for you. Like, for example, I prefer actually writing automation inside of SMA because I can create a workflow faster by typing than I can through drag, drop, click, 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 right? So kind of as a preference that you might have on how to do that, whether you like to type and do it that way or you prefer a drag and drop. Okay, so there's a few other points there. We'll kind of skip over those in the interest of time. So in terms of integration between SMA and SCSM, let's look at kind of an architecture diagram. So starting here at the bottom, we have Windows Workflow Foundation. That's the underlying technology for SMA. We have PowerShell, where we can execute PowerShell scripts within the context of a PowerShell workflow as well. And then on top of that, we have the service management automation runtime. And this is the engine that executes SMA workflows. On top of that, we have the service management API. And this is the API layer that the Windows Azure Pack Admin portal connects to. And there are also some PowerShell modules that are provided as part of SMA that call into that API layer as well. And then there's a database which is used to store all of the information about SMA. Now up here we have the integration that Cyrusson provides between Service Manager and SMA. So there's a connector that we provide that does a couple things. One is it introduces a new SMA runbook activity work item type that you can include in service requests, change requests, release records, incidents, whatever you want to automate all or portion of a process of implementing a particular work item. So for example, if you had a service request to onboard a new user, you might have a manual activity in there and a review activity to approve it, and then you might have an SMA runbook activity. And when that activity becomes active in that process, it can call out to an SMA server and kick off that runbook. We also have the ability to subscribe to changes that happen in the database, either new objects that are created or updated, and where certain conditions are met. And when that happens, that can also trigger an SMA runbook. And I'll show you an example of using this here in a few minutes. But this connector enables kicking off these SMA runbooks and monitoring for their completion and updating Service Manager when it's done. So let's go ahead and take a look now at a demo that we created of using the service management automation integration for managing this feedback cycle. All right. Okay, so right now we're inside the Cyrusson portal here, and we're going to submit a request as an end user having some kind of an issue that we need to then forward on to dev. All right, so we'll log in here. All right, so to begin with here, we'll just file a data setter incident. We'll fill out this form here. We'll call this just a NIC demo, some details. Pick which computer we're having the problem about here. Pick the urgency and impact of the issue. When this issue first started happening. And we can also attach a file. All right, so once we're done with that, we'll hit save. This will create a new incident. And now I'm going to put my IT guy hat on. Okay, so that was as an end user. I'm going to put my IT guy hat on, and I would go and investigate this particular issue and see what the problem seemed to be. And if at the end of that I determine that this is actually some sort of product or code defect bug, then I would be able to check this box here, send to TFS. So by checking this box here, this will trigger an SMA runbook to send this work item to TFS. So let's take a look at what that looks like here. So this is the Service Manager console. I'm going to go into administration. Oh, sorry, I'm looking at the wrong Service Manager console. Look at this Service Manager console. Okay, so we have our send to TFS workflow here. Let's look in here. So here's where we configure our send to TFS workflow. So basically, the criteria for this workflow is whenever an incident is updated, we want to look at the send to TFS property, and if before the update the send to TFS value is false, and after the update the send to TFS value is true, so in other words somebody checked the box, then we're going to call our SMA connector here and call the new TFS work item SMA runbook, and we're going to pass some parameters to it. So first of all, we're going to pass the incident ID and the incident GUID, and we'll also pass the incident title into our runbook. Okay, so now let's go and look at what this runbook looks like. So now we're inside of the Windows Azure Pack admin portal. We can see that this runbook is currently running, so the service manager has now kicked this off. But let's take a look at what this runbook looks like inside. So if we go to the Author tab, we can see exactly what's going on here. So we've got a workflow that's declared, similar to what I just showed you in the introduction to PowerShell workflows. We've got some parameters that are being passed in, and as you can see, these map to the parameters I just showed you for the workflow configuration in Service Manager. So this is how the incident GUID, incident ID, and title are passed in as parameter values to this PowerShell workflow. And then we've got an inline script here, and we do something kind of tricky here, which is where we use the using command to take the input parameter values here that are outside the inline script, and we assign them to variables inside the inline script block. So this is what I was referring to about how variable lifetime is handled differently with PowerShell workflows. Okay, then we instantiate the TFS SDK library here by calling these commands here. So these are just DLLs that are provided as part of Team Foundation Server. And then we create a connection to our server here, okay? And then we call into the work item store, and we get our work item store, and then we get a particular project. In this case, it's going to be our portal project. And then we're going to get a work item type, which in this case will be bug, since we're converting an incident into a bug now. And then we're going to create a new work item. We're going to set the title of that work item equal to the parameter value that was passed in from Service Manager, plus the ID of that incident in parentheses. And then we save it. And then we take the ID that was passed in, we get the object in Service Manager, the incident object in Service Manager, and we set the TFS ID property value on that incident equal to the TFS work item ID, right? So we're getting this Service Manager incident, we're taking that and we're going and creating a new TFS work item in TFS, and we're putting the Service Manager ID in the title of that TFS work item, and we're taking the TFS work item ID and we're storing it on the TFS ID property on the incident. So if we take a look at what this looks like now inside of Service Manager, we can see, assuming this is, looks like it's not quite done yet. Looks like it's completed. Why did I not get my TFS ID here? Why do demos never work? Kills me. Even though you try them like 5 times before you come into the room. So that's 212, says it completed. Well, here we go. Has some errors. It's probably because I put a space in my title or something. Anyway, I won't debug this now. But the idea is that you would get that TFS ID put back here into this particular property value, and then that work item would be created inside of TFS as well. And then we also have the ability to monitor for a TFS work item to be resolved inside of TFS. And when the work item is resolved inside of TFS, we can update the incident status to be resolved as well. So let's take a look at what that runbook looks like here. Okay, so I've created another work item called Sync TFS to Service Manager, and we can look at what this runbook looks like. Okay, so this one here starts out by using the SMLets PowerShell module to get Service Manager objects where the class is incident and the filter is TFS ID not equal to null. And for each incident in that collection, we then get the TFS ID property of those incidents and the incident ID. And then we have an inline script block here where we instantiate the TFS library again. We get our project collection, we get our work item store, and then we look for each work item, right? So we go through and we're for eaching through each of the TFS incidents, and we go and get the TFS work item by the TFS ID that's stored in that incident. And once we have that TFS work item, we check to see if the state of that work item is resolved. If it is resolved, then we get the resolved enumeration value for incidents, and we get the incident that is that same ID for that incident, and then we set the status property of that, of the status there to be resolved. So in this way, we can kind of complete the cycle. So somebody puts in a TFS work item and says, okay, I have this bug, the IT team triages it, they send it to development works on it, fixes it. Once it's resolved there, then we can have this workflow automatically pick that up and update the status of the incident to be resolved so that the customer gets notified. So we can actually automate that complete feedback cycle. So this is one example of using SMA to do this. If we were to, sort of make this more official and productized, we'd obviously add a lot more capabilities to this and put in some error handling and things like that. But hopefully this gives you an idea of how you could use SMA to achieve this feedback cycle. All right, so. Okay, for the rest of the demos I'm going to show you today, these are real world examples. These are things that are actually running in our production system. So, as I've talked about at the beginning, Cyerson has this self-service portal that we provide to our customers. It is our own product. Customers interact with us to get support through that. And it's all built on top of Service Manager. And we operate an instance of Service Manager and Cyerson Portal in Azure to support our customers. And every 2 weeks, we produce a new release of the Cyerson Portal software, and we upgrade our production instance of that Cyerson Portal with our new version. And we do that before we even give that build to our customers. We install it in our own environment, use it for a few days, make sure it's looking good, and then we provide it to our customers. So, and we've automated the feedback cycle in our own production environment. And so what I'm going to show you today is how we've done that using SCSM and TFS workflows. So the first thing that we did is we extended the data model inside of Service Manager to add 2 additional properties to the incident and service request classes. We added a send to TFS property, which is a Boolean, similar to what I just showed you here in the demo within my dev environment. And we added a TFS work item ID property. So obviously send to TFS is a way for us to say, okay, this incident or this service request needs to be sent to TFS. And it's also a way for us with TFS work item ID to capture the TFS work item as part of the incident or the service request. And then we've also extended the analyst and end user comment log class to add a new TFS comment added date. So we are also synchronizing comments back and forth between incidents and service requests as well as TFS bugs and user stories. So let's talk a little bit about how this works. In general, Service Manager has a workflow infrastructure that looks like this. You've got the database, right, SCSM database, and you can have 2 different types of workflows. The first type of workflow is a subscription workflow. And a subscription workflow pulls the Service Manager database looking for certain conditions to trigger the workflow. So you might look, for example, for a new incident to be created, Or in this particular example, you look for an incident to have its send to TFS property value change from false to true. You can also set up workflows to run on a schedule. So every 5 minutes or every 1 hour, whatever you want to have, you can set up a workflow to run on a schedule. Whenever that trigger condition happens, then Service Manager will execute a Windows Workflow Foundation workflow, and that workflow can optionally call back to Service Manager through the SDK library to the Data Access Service web service, which is a Windows service running on a Service Manager management server, back into the Service Manager database and either update data that way or retrieve data that way, whatever the workflow needs in order to be able to execute. So the first workflow that we created to enable this scenario is a new TFS work item workflow. The new TFS work item workflow looks for incidents that are created with the send to TFS value equals true, or the send to TFS value changes from false to true. In either condition, we want to create a new bug work item in TFS and store the Service Manager ID on the TFS work item, and then also update the incident or service request with the TFS work item ID. So in the management pack XML, it looks like this. The first big circle that we see here, this is the ID of the incident class. So we're subscribing to instances of the incident class that are added. That's the add instance element here. And we're looking for the send to TFS property value to be equal to true. So that's how we set up the trigger condition for this particular workflow. The update workflow is similar. We're looking for, again, incidents where the incident has been updated, and the criteria is before the update, the send to TFS property is equal to false, and after the update, the send to TFS property update value is true. So it's transitioning from false to true, and we want to capture that. That effectively means that somebody checked that box and wants to send this work item to TFS. The other type of workflow that we created is for a new action log entry. So whenever an end user or an analyst adds a comment to the action log, we want to subscribe to that and take that comment that was provided and update TFS with that comment. So in this particular case, we're subscribing to those relationship objects being created. We look up the TFS work item ID in the parent work item, and then we go and update that TFS work item history. So a subscription workflow criteria looks like this. You specify the relationship type that you want to subscribe to, and whether you're looking for an add or a remove relationship. In this case, we're looking for an add. Okay, then on the TFS side, we want to monitor for work items that are updated. Either the TFS work item status changes to closed, in which case we want to update the Service Manager work item, or we want to take a comment that's added to the history of a TFS work item and copy that into the action log of the work item in Service Manager. So to do this, we created a TFS plugin, and you can see the beginnings of the code here, where we just instantiate a new subscriber and define the code that we want to execute inside of there. When you compile a TFS DLL, then you just copy that DLL into this plugins directory here. And if you want, there's a helpful video here that I've linked to that you can get more information on how to do this. So now let's see a demo of this working end to end. All right, so again, this is sort of this is our production environment here that we'll be demonstrating in. All right. So we'll do a similar scenario here this time where, where's my mouse? Here we go. Okay. So this time, did I lose my internet connection? Nope, I lost my internet. Hang on. Okay. All right, so this is our production instance running on Azure now, and I'll pretend that I'm an end user this time and I'm going to request some feature. So I'll go to the feature request form here, and I'll do NIC demo feature. Okay, and then I'll choose the self-service portal as the app I want to request the feature about. Provide some description here and click save. So this will create a new service request in Service Manager for this feature request. So we'll drill in on this now. And as a product owner at Cyrus, I would look at each of these feature requests coming in and decide which features I wanted to go ahead and forward on into our backlog in TFS. So I can go to the TFS tab here and click on the Send to TFS checkbox and hit Apply. And what this will do is this will kick off the Send to TFS workflow. So here we can look, oh, we lost our connection here too. All right, so inside of Service Manager's console here, this is going to take too long after we lost the connection here. We'll just wait here for this to update. I was going to show you the status of the TFS workflow executing inside of Service Manager. But here we should see within a few seconds that the TFS work item ID will be populated here inside of our work item. Okay, hopefully this is going to work here. Okay. So what's going on here behind the scenes is that the workflow that's subscribing for incidents that have the Send to TFS checkbox checked is going out and calling out to TFS to create that work item inside of TFS. And this is interesting. It's almost like there's some problem with TFS, and that's why the other one failed as well. All right. Well, we may have to look at a different example here that I already did as part of a preparation for this. I think that's what's going on. So let's go back. Let's look at one that I did previously here. So this is the test that I did right before we joined or came into the session here. So here, the TFS. What? Oh, they're on my closed tab. Sorry, I'm looking at the wrong ones here. Sort by created date. Okay, so here's the demo test I did earlier. Okay, so here we've got a TFS work item ID of 3254. So once I checked the box here, it went and created a work item here at 3254. If we go into TFS and look up that work item, we can see that it started out here, it copied over the title of the service request, the feature request in this case, and it populated whatever the description was of that service request in the details property of the user story here. So user stories are the things that you have in your backlog. And then here on the history tab, we can see that there was an exchange of comments between the person working in TFS that made this comment here, and then over on the incident, the person made, or sorry, service request in this case, the person made some comments down here in the action log that were, this is a comment from service manager that then showed up over here on this side in TFS. So this way, the developer and the IT people and the end user can all have a conversation about this work item and have that information synced into the service request or incident inside of service manager, as well as the user story or bug inside of TFS. And that way, everybody's using their own tool, right? The developers can use TFS, the IT people can use Service Manager, and the end users can use the self-service portal that they're familiar with. Once I changed the status of this user story to closed, meaning as a development team, we've completed implementing this user story, that automatically updated the status of the service request here to completed, and then I manually closed it, and that's why it ended up on the close tab. But that way, the end user can be notified that their feature request has actually been completed automatically. Similarly, with incidents here, let's go look at this real quick. On the incident side, we can see on this closed incident that I created here, same thing happened, right? I created an incident, I checked the send to TFS box. This work item ID was then copied in or created inside of TFS. So here's the demo test incident that was created as a bug inside of TFS. And then same thing happened here with the comments. You can go back and forth on the comments here as well. And then once the status of this bug was changed to closed, meaning that the development team has fixed the bug, then the incident status is changed to resolved, and the end user is notified that that bug has been resolved. And then once the end user confirms that that issue is no longer present, they can close the incident. So this is a good example of how we can use Service Manager workflows and TFS workflows and the Service Manager and TFS SDKs in order to be able to communicate back and forth between Service Manager and TFS to automate this feedback cycle. So next I'd like to talk about release management and automating that process. So this is the other side of the feedback cycle. We've been talking so far about kind of the providing the feedback and responding to that and prioritizing and working on it. Now we're over on the other side of the feedback circle where we're working on automating release management. So if you think about it, in order to get a build out to release, it needs to go through all of the processes in dev and all of the processes in IT. So the developers on their side are using a tool called Release Management for Visual Studio, and the IT people on their side are using a Service Manager's Release Management. And what we want to do is we want to coordinate these two efforts because there's a lot of dependencies oftentimes between development and IT. So on the Release Management for Visual Studio side, the development team is coordinating the release of that new build to different environments for testing, and they're coordinating approvals, and they're deploying that code into those environments and configuring it in order for it to be tested. The IT team on their side is coordinating a different set of approvals and doing a lot of communication around preparing for that rollout and communicating out to the end users that this new release is coming. There's a lot of communication that has to happen about, here's a new release, here's the new features, let's get you trained on it, let's have a promotion campaign about it. If it's an external product that's being released, there might even be some marketing efforts around it and so on. And the IT team probably needs to do some acceptance testing within the production environment before it actually goes live to customers. And there is probably a lot of environmental configuration that needs to happen in order to prepare for that release. So really, I want to just kind of show today some automation that we can do between Service Manager Release Management and the Release Management for Visual Studio. So I'll just do a demo of that now. Okay, so the first demo that I'll show you is how, as part of a development process, the development team can create release work items inside of Service Manager. So what I've done is just created a simple project here that all it does is connect to Service Manager, get a release record object template, and then create a new release record based upon that template. And that's all it does, right? And so this is just a very simple example of how I can create an automated routine to create a release record based on a certain template. Then I created a simple project just for demo purposes here called DemoDB. And as part of this build process, it has an automated post-build event command line that's executed, which executes that executable I just showed you the project for that will create a release record inside a Service Manager. So when I now build this project here, we'll see that once this build is done, it calls the command as part of the post build, and that will create a release record inside of Service Manager. So if we now go into, where did I create that? Can't quite see the UI there. So I've created a view just for this demo here of all the release records. Okay, log in again. Okay, so here's our release record that was created. And this release record is based upon a template. So the idea with a release is you want to have it be as standardized as possible. So for every release that you have of a particular application, you want to follow the same process over and over again. So you create a template of that process. And you can define the release package, which could be the configuration items that need to be modified, which services are going to be affected. You can define the schedule of that release. And here's where you define the process of the release. So in this case here, I've created some different steps in this process to test the build in a particular environment. We're going to automate the lit testing, and then we're going to approve the release to production. So you can define whatever process you want to have in here, and it can be pretty complex if you want. You can have nested parallel activities with sequential activities and create a pretty big hierarchy of different activities that need to be involved in producing a release. Okay, then normally you would probably do this as part of the release management process inside of TFS. So that's what I want to show you next. You could do it as part of the build process as I just showed here, or it could be an automated step inside of the release management process in TFS. Okay. Sorry, I've got to connect to the server again now that we lost internet access. Okay, now, before we dive in to look at all this here, I want to kick off a release. So the way that the releases work in our environment is I receive an email notification like this. I go up here to the release management UI, and I approve a release. So in this particular case, I'm going to approve a release to our staging environment. And what will happen here is that our server that is sitting at this environment here will be automatically upgraded by our deployment here. So right now you can see that our portal is up. In a couple minutes here I'll come in and we'll see that our portal will be replaced by what we call our gone fishing page, which just lets everybody know that our site is currently unavailable because we're working on it. And then after a few more minutes it'll actually be fully upgraded to the next version. So let me just show you kind of how this works inside of TFS while this is going on. So this is the release management UI as part of Visual Studio now. And we've defined some process for how we're going to deploy this app. So first we start out as a deployment to our kind of test server first. In this case, I've disabled all of those steps so we can jump right in. But the sequence of activities here is that we stop the production website, or in this case, the staging website, and we start the Gone Fishing website, which is a website that just has a simple interface on it that tells people that it's unavailable. And that just sits on the same port. So whenever somebody accesses our site normally, they'll get this new Gone Fishing website instead. Oh, I'm sorry, guys. I'm sorry. Okay, there we go. All right, so here's the sequence, right? We stop the website. That's our SCSM portal website. We start the Gone Fishing website. Then we begin the process to install the portal. And then we have a way that we package a click once application. And so that's these next two steps here. So we package up the new click once application and we modify the previous click once application so that it's archived and available for people to download. And then we deploy the portal site. Then we stop the Gone Fishing website and we start our production SCSM portal website. Plus a sequence of events. Behind each of these is typically like a PowerShell script or some code that we execute. And as I mentioned, one of these steps here could be to create a release record inside of Service Manager. And you could also have some back and forth communication going here between Service Manager's release management record as well as the release management here inside of TFS. So you could have a step in here that updates something over on the release record inside of Service Manager, or you could have a step inside of the release record in Service Manager that's kicking off or updating something here on the release management side inside of TFS. Now, one other thing that I'll show you here is kind of our releases. So actually we'll show you paths. So for paths here, this is the path that we're on for deploying an alpha release, which is what we're doing right now. And that's just simply has two environments. The first environment is like a pre-release deployment, and then the dev testing environment is the one that we're actually deploying right now. But you could also define a more complex path as well. So you could have, for example, our RTM release path is more like 5 or 6 environments that we use to roll out to production. So let's take a look at that path here. That's this one here on the bottom, the RTM release path. So each of these boxes here represents a different environment that we automatically deploy into. So we'll deploy into dev testing first, we'll do some testing there, and then somebody will be assigned to accept that, in this case Lance, who's our architect. And then it goes on to the next step, we test some more there, somebody approves that, it goes on to the next step, and then eventually we get all the way out to the point where we've released it to our customers. And this entire process is completely automated, so all we have to do is simply approve a particular step in that process, and it goes on to the next step in the process automatically. Okay, so this is an example of our Gone Fishing homepage right here. So this is what people would see when we are having some maintenance going on. So if you guys aren't familiar, IT Monkey is like our mascot at SCSM. We have little IT monkeys at our booth. Definitely swing by and get one. They're really funny. You can fling them across the room at people. So everything we do at SCSM is all about IT Monkey. So in this case, IT Monkey's gone fishing, and he's left us here to do some work. But in another couple of minutes here, this release will be completed. And actually, I just got an email that looks like the deployment was unsuccessful, but let's try it anyway. Okay. I think it's probably not going to work because I got a deployment failed email here. But that's kind of the idea, is that you got this automated process of things going, and end-to-end you can automate that process of release management and tie it in between the IT guys and the developer guys so that they're working together on a release. So to kind of wrap up here, automated integration between Service Manager and TFS enables IT and dev to collaborate while still using their own tools. We don't want to try to get dev to use Service Manager. We don't want to get IT people to use TFS. We want people to use their own tools, but coordinate between each other based upon these work items that exist in Service Manager and TFS. And we can align our two different processes. Dev uses Agile, IT uses ITIL. that doesn't really matter as long as we coordinate on kind of the foundation level, which is that everybody's got work to do. That work is being tracked by work items in Service Manager and TFS, and if we can coordinate those work items between those two teams, then we can coordinate even though we're using different process frameworks. And then lastly is by using an approach like this, the IT team can be an essential part of the feedback cycle of receiving that feedback from the customers, providing that through to the development team, and then on the other side, having the release be a part of something that's just coordinated between dev and IT much better than it normally is, because everybody's using a coordinated release framework basically. And the result of that can be much better responsiveness to customers' requirements. That's what Agile is really all about. And having a smoother release cycle, which everybody can really appreciate because you can go home and sleep better at night knowing that the release went well. And ultimately, that just results in more agility for everybody. And that's kind of what I wanted to come across today, is just how we can use this automation to enable that agility and let us do more important things other than trying to coordinate things, right? Try to use this automation to make that part of our jobs much easier. So thank you guys very much for showing up, and I'll be available up here for any questions that you might have, and I'll be over at the Cyrusm booth as well if you want to talk about how this was all implemented over there. All right, so thank you.
I think the demo got to